Okay, so last class we were implementing Towers of Hanoi using a, actually that's not us, right? We were doing tic-tac-toe, correct? 535. All right, so we implemented tic-tac-toe where we created a tic-tac-toe object that we named game, and then we told that game to go ahead and play. Well, what's a tic-tac-toe object? It's one of these guys. It's a collection of a board. Then there was a variable to keep track of the current move, so the X or the O, who is the next move. This guy's the constructor, where we said X's go first. And we went ahead and we created a board here in the constructor as well. So if we go back and look at board, what's board? That's a two-dimensional character array that we initially filled with underscores, right? And so it's a 3x3 grid for tic-tac-toe. We went through and filled it up with underscores. And then a board also knows how to report to us whether or not there's currently a winner. So we have a Boolean expression here for all 8 different ways you can win on a tic-tac-toe board. And then we returned all those guys ORed together. If any of them are true, if there's a winner in the current board across there, it'll return true. Otherwise, it'll return false. We have a make move for board where we give it the row and column that the move should be made, as well as the whether it's an X or an O being moved. And if there was currently an underscore there, which means it's a legal position that you're allowed to move into, we'll make the move and return true that a move was allowed to happen. Otherwise, we'll return false and not actually make the move. And then we taught a board how to display itself. We just spun through and we kind of showed the current state of the tic-tac-toe board, right? So we get back here to tic-tac-toe. We have this play method, which creates a scanner for reading stuff in from the user. And as long as the board doesn't currently show a winner, so as long as is winner equals false, we'll go ahead and show the user the board, print out for them to pick a row, read in the row, print out for them to pick a column, read in the column, and then we'll try to make a move. This is our make move. This is tic-tac-toe's make move function. That's this guy down here that takes in a row and column, and it tries to make the move with the current move. All right. So if the move was successful, if we successfully actually made the move, they gave us a legal move, we toggle cur move. If it used to be an X, now it becomes an O. Otherwise, now it becomes an X, and we'll return true. Else, we'll go ahead and print out in red that this was an illegal move and return false, and current move did not change. Okay? So that's how tic-tac-toe worked. For our homework, we were supposed to use this as a model and create the game Connect 4. All right? Now, the board for Connect 4 works a little bit differently. All right? That is, Connect 4 has, 7 columns, 6 rows, or is it the other way around? Other way around. So 7 rows, 6 columns. Okay? Now, when you make your move, you're not picking a row and a column. You're picking just a column. Which column am I going to drop the checker in? And that checker is going to try to fall as far down that column as it can until it lands either on the very bottom or on top of another checker. Does that make sense? Okay, so the mechanics of the Connect 4 board are a little bit different than the mechanics of the tic-tac-toe board. Okay, tic-tac-toe board, we gave it a row and column, we tried to make the move there. Okay, that's not how it works in Connect 4. Connect 4, we pick a column, let the checker drop, it drops as far as it can drop, and that's the deal. Okay, so we'll keep our driver out here. And we'll keep using this same class here, the same project. So what we're going to do is I'm going to create a new board object called C4 board, Connect 4 board. Get it? Haha. All right, so we'll go ahead and we'll create a new class. And we'll name this guy C4 board. All right. So this is going to represent the actual board for us playing Connect 4. All right. And you mentioned that this guy is going to be a, so we'll make it a private two-dimensional char array. We'll call this guy the board. And then public C4 board is going to say this dot the board is equal to a new char array. And this is rows by columns. So you said it's 7 rows by 6 columns.
6 rows.
So 6 up and down, 7 across. Yeah, that's what I said originally.
Oh.
And then you corrected me.
Not bad.
All right. All right. So 7 rows, so 7 tall, right? Okay, and 6 across this way. All right, good. Okay, so that'll be the board. All right, now let's go ahead and teach our board how to display itself, and this is going to look pretty similar to our old board guy here. In fact, we can just steal that display method. It's the identical display method, right? Because it's done in terms of the length of the rows and columns. So there's display, and I happen to choose the same variable name for my board, so this will display my current board. Now, we probably want to go ahead and give ourselves what an empty board looks like. Okay, so we'll go ahead and fill this guy up here. In fact, I'll steal this little, let's steal this for loop here. And we'll say this dot the board at bucket ij is equal to the underscore. So that'll fill the board up. Okay, let's go ahead and test our board, make sure that guy's doing what we think it should be doing. So we'll come in here. And we'll go ahead and we're going to create a variable of type C4 board. We'll just call this guy board. Is this going to be equal to a new C4 board? And then we'll say board.display. Okay. And this should give us our what looks like a Connect 4 board. That guy right there. So this is what it looks like. 6 across, 7 up and down. Okay, so now that's showing the current state of the board. When we make a move on the board, what we want to do is we want to have a checker drop down a column as far as it can drop until it either hits the bottom, right, or it lands on top of another checker, okay, another checker. So when we write make move, this guy's just taking in the column in which we're going to drop that checker. Okay? So when we have the column, we go, we can actually just bring up a Connect 4 board here. All right, this guy right here. That looks like 7 across and 6 up and down. 7.
The most commonly used one is 7 columns.
Okay, that's fine. It doesn't matter. You said 7 columns, 6 rows.
Yeah.
Okay, so now this is rows. This is columns. So when I run this right now, well, this guy's going to be, just get rid of that for a second. This is column 0, column 1, column 2, column 3, column 4, column 5. This is row 0, row 1, row 2, row 3. So as I currently have it, I have 7 rows and I have 6 columns. This board I'm looking at right here, what you're saying is the most common, is 7 columns. And there's also, and then there's 6 rows in this. So this is 6 by 7. So everybody understand the difference between rows and columns? All right. So this should be our new board. 6 rows, or 6 columns across, and then it is 7 tall. So now we have it represented like this. No, we have it as 1, 2, 3, 4, 5, 6, 7. 7 across, and should be 6 tall. 1, 2, 3, 4, 5, 6. 6 tall. Okay, so now we're equal to the the official whatever. Now, if I pick column 0 here, okay, I'm showing the board, and I pick column 0 and I drop a checker here. We can think of any of these empty circles as being our underscores, right? Well, as I fall, I'm starting off this is row 0, column 0, row 1, column 0, row 2, column 0. So row increments, column stays the same as I fall through here, right? Okay, so as I go down, I'm going to drop the checker. So am I allowed to put the checker here? Sure, but it's going to keep falling. Can I put it here? Sure. So what's the best way of doing this? If I choose this column, I can go all the way down to the bottom. So this is column 0, row length minus 1. And say, is this guy available? If yes, go ahead and place something. So we'll place it. We're done. Now if I chose column 1 here, I'm going to go column 1, row length minus 1. Is this guy available? No. Bounce up 1. Is this guy available? No. Bounce up 1. Is this guy available? Yes. So go ahead and make the move. Okay? And if you get to one where you've gone all the way up to the top and you finally move to a row -1, that means it was an illegal move to begin with. Right? You chose a column that was filled. All right, that makes sense? So rather than thinking about this as dropping a checker in the top and letting it fall as far as it can, let's go to the farthest it might be able to fall and then work our way back up to give it a final destination. Okay? So for our make move, we take in a column. We're going to say int cur row is equal to this dot the board dot length minus 1. Okay, that's the first place we're going to try to put it at, position call cur row. Now we can error check and make sure they gave us one of our legal columns, but we could assume that they gave us a legal column for this. You know, that they didn't choose column 600 or column -4. You know, we can assume they're going to give us column 0 to column 5. Or column 0 to 6. We have 7 across. Okay? So now we're going to, I guess, really keep trying to place the, we're going to keep trying to place our checker. Now, we don't know what the cur move is yet, so for right now, let's just assume all moves are the same. Okay? So the question would be this. How many times, how many things are we going to have to check before we can place a checker? So if I choose column 0 or column 1 or column 2, whatever column I chose, how many different places am I going to have to check before we can actually place the checker? Do we know? We don't necessarily know, right? Depending on the column and depending on the current state of the board, that checker might be able to fall all the way down. It might fall halfway down. It might fall almost all the way down. It might not fit at all. We don't know ahead of time, right? So we talked about different kinds of loops. We have while loops, we have for loops, we have do while loops. Well, up to this point, we've been using a lot of for loops. Okay, for loops are pre-check loops, so we check the Boolean expression first. But they lend themselves to the kinds of problems that are counting type problems, where we know how many times we want to do something. A while loop lends itself to the types of problems where we don't necessarily know how many times we need to do something. Now, having said that, you can use any of the loops to solve any looping problem. All right? But it kind of makes sense if you have a computer program that says press any key to continue, right? Then you got the joke, well, where's the any key, right? But how long will it be until somebody presses a key? Might be 2 seconds, might be 2 minutes, might be 2 weeks, might be 2 years. We don't know, right? So what we're going to do is we're going to keep checking. Has a key been pressed? No. 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 Over and over and over again until somebody finally presses the key. Does that make sense? So we don't know how many times we're going to have to. We know the maximum. We know the total number of things that we're going to have to check here is 6. The height of our board, right? That's worst case. Okay, I'll try to put it in one of these 6 places. If it doesn't fit in any of them, then we'll bail. So what I'll do here is I'm going to say while. Now there's actually a couple of ways we can do this, but let's do it this way. We're going to say while this dot the board at bucket cur row and col is not equal to an underscore. Okay? So while it's not illegal, okay, while it's something other than an underscore, or I'm sorry, while it is illegal, while it's a place I can't place a checker, is this equal to an underscore? No, it's not. Keep going. Is this equal to an underscore? No, it's not. Keep going. Is this equal to an underscore? Yes, it is. I'm good. All right. But we do need to make sure that we eventually get to the thing where we also check to make sure that cur row is not -1. So there really needs to be 2 pieces of this. So as long as cur row is greater than or equal to 0, and so while both of these things are true, as long as I have a legal row I'm looking at, and because I started cur row off at the last legal position, I'm going to work it towards the first legal position. So as long as cur row currently is a legit row, and the board that I'm currently looking at is not a legal move position, then I need to go ahead and move cur row up. Keep checking, right? So we'll say cur row. Sure, go ahead.
Smart enough to know that the size of the array.
It does know the size of the array. It's called this dot the board dot length.
Right, but then you still have to check for -1.
You mean why do I have to do this?
Yeah.
Because what's going to happen when I say this dot the board at bucket -1, 2?
But it already knows the length of the board.
It knows it, but it's still only going to do what we tell it to do. So if I say, hey, board, because I have my 2-dimensional array there, go ahead and give me whatever's at row -1, column 2. The value that goes in here, it has to be numeric. Nothing keeps the stupid human from putting a -1 in there or a -2 in there. So if we give this guy bad input, it's going to crash. It's going to say, oh, okay, well, we have an array index out of bounds exception. You tried to ask for something at row -1. Row -1 doesn't exist. The first legal row is row 0. So it's not that it's not smart enough. It's, it doesn't necessarily know at runtime the size of this guy, or at compile time rather. It doesn't know what cur row is going to be when I compile this. It doesn't know the length of this guy when I compile this. We happen to know what we defined it as, but we have no idea what value we're going to try to make cur row. So it's like these are generic placeholder values. So it doesn't know that this guy could sometimes be a problem. So that's why we have to put in our own logic to check that we're not going to even try to ask this question unless we know for a fact that cur row is a legal row. We happen to know that cur row is starting off at the last legal row, and we know it's going to be moving towards the first legal row. So before we even try to check these buckets for legality, we're going to make sure that cur row is within the correct threshold of allowable rows. Does that make sense? So maybe the generic answer to your question, you said, why isn't the program smart enough? Programs are not smart. They do exactly what we tell them to do. So they don't know what our values are going to be at runtime. That's up to us. Okay, so we need to do any sort of checking because they're not supposed to be smart. They literally, language is just our way of telling a computer exactly what to do. We have to do all the checking. All right, so we'll start at the bottom of the board. And as long as we're not allowed to make a move, well, this says, is the row legal and is the current thing we're looking at already occupied by a checker? That's what that says. Then let's go ahead and move up. And then we'll check that guy the next time around through the loop. Then we'll move up. We'll check that guy the next time through the loop, so on and so forth. Okay? When we finally exit this while loop, one of two things is true. Either cur row is below 0, which means that we have a full column. We were not able to make a row. That means we checked each place as we walked up, and we didn't find any of them. We finally did cur row minus minus and went off the top of the grid. This whole thing was filled up, and now cur row is up here. All right? So we can ask the question, if cur row is equal to -1, go ahead and return false. I wasn't able to make a move. Column was full. Illegal move. Else, cur row must be something other than -1, which means it must be 0 or greater. Therefore, we can go ahead and make our move. And right now, let's just default it to, I don't know, a 0 for there's a checker there. All right. So else, we'll say this dot the board at bucket row cur row call is equal to, and we'll go ahead and put the char 0 there. And then we'll go ahead and return true. Now this isn't toggling back and forth between moves yet, right? We'll do that next. Let's just make sure that we can kind of mechanically work with our board. All right, we're taking baby steps here. Before we try to apply the rules of Connect 4, we have to make sure that the court is working. Okay, or we soccer or cricket fans in here? Cricket? Is it the cricket pitch? Is that what it's called? It's the soccer pitch and the cricket pitch. What about rugby? Do we watch rugby? That's not one of our sports. You watch rugby. Yeah, see, that's why you started your homework late. Wasn't there some big game between England and Italy on Sunday morning, right? England won. See, I follow rugby religiously.
I don't too much. I just watch because now cricket is going on.
I don't actually follow rugby religiously. Just one of my good friends, Skip Church, he's British, and he's used to play rugby, so he's a rugby fan. So I was texting him during church on Sunday, asking him how it was going. I told him I bet a bunch of money on Italy, and then I'm like, that is who they're playing. Okay, so let's go ahead and mechanically see this guy work. Well, in order to do that, we're going to have to kind of throw our logic in there for our game to ask for which column and that stuff. So let's go ahead and do that. So we'll go ahead and create our Connect 4 object. So new class Connect 4. All right, and Connect 4 is going to have a, did I talk about public, private, protected yet? Or I just say, okay, I told you what those mean, right? Okay, and we'll keep elaborating on them, but I just wanted to make sure I did. So making something private means it's only accessible inside of this class. Public means it's accessible everywhere, and protected we don't know yet because it's that deals with inheritance, which we haven't dealt with yet. All right, so private, we're going to have a board. So this is what, a C4 board? Call that guy the board. Then we'll have our public constructor for this guy, and constructors always match the same name as the class name identically. We'll say this dot the board is equal to a new C4. Come on. Killing me. C4 board. Then we'll go ahead and give ourselves a public void play. All right, and this is where we're going to probably give ourselves our scanner. So scanner comes from java.util, so we need to import that. And we build it in terms of what input stream we want to use, and we don't really know about input streams yet, but we know about one called system.in, which is the standard input stream, which is our keyboard. All right, but kind of rolling forward a little bit, if you wanted to read something in from a file, which we will do in our not this assignment but the next one, you'll use scanner to do that as well. You just won't read in from the keyboard, you'll read in from some input stream associated with that file. So the exact same tool, we just give it a different source that we're reading from. Okay, something to kind of look forward to there, I guess. So scanner input is equal to new scanner. Then we're going to go ahead and for right now, let's just do while true, just so we have an infinite loop that we can just keep asking for a column and trying to make a move and that kind of stuff. All right. So we're going to say this dot the board dot display. So we'll show them the current state of the board. Then we'll say system dot out dot print which column. And then we'll say int col is equal to input dot, man, this keyboard's killing me. Next int, so I'll read in the column they chose, and this, again, we're assuming they're going to give us an actual legitimate input. Okay. Then we'll go ahead and try to make that move, and we're not even going to question it at this point. We'll say this dot the board dot make move, and we'll give it the column we just read in, and we'll just have that do that forever. Right now, we should be able to mechanically see our board work. Okay, so that's all our Connect4 object does right now. It maintains a single board, a C4 board. When it gets built, it goes ahead and instantiates that board. So it gives us, this guy is our real estate agent, gives us some memory for that board. All right, and our C4 board is this dude right here that ends up starting off as a standard board with a bunch of underscores in it, and then it has the ability to make a move given a column. Okay. Then we have our play method here, and all the play method says is, you know what, forever, I will show you the board, ask you to give me a column, and then I'll try to make that move. Forever. I'm not checking for winners, I'm not doing anything, just this goes on forever. Make sense? All right, so let's go back out then to our driver, and let's go ahead and do a Connect4 game. Connect4 game is equal to a new Connect4. And we'll say game.play, and that should get the ball rolling here. Go ahead and hit play. There's our current board. Can I make this guy bigger? Awesome. All right, so we'll go ahead and we'll say column 0. It made our move down on column 0. Now if I say 0 again, it should let it drop all the way to the bottom, but on top of the previous guy. If I do 1, if I do 2, if I do 3, then I do 3 again, then I do 2, then I do 4, 5, 6, 6, 6, 6, 6, 6, we're still good. Now, if I do 6 again, it should not crash. We just know behind the scenes it returned a false, right? So now I can just do 5. Oh, I think I put a backslash in there. All right. See, I told you I hate this keyboard. I can't program with this keyboard. Terrible. All right. I think our board works, right? All right. So now we're never going to get an error from our board as long as we type in legitimate inputs. But, all right. Well, now what we need to do is we need to be able to toggle back and forth between moves. Okay. So you could do this a couple different ways. You might choose to have, traditionally in Connect 4, the 2 checkers are red and black. So you might decide to toggle back and forth between R and B, something like that. Isn't that like a style of music, R and B? Yeah, see? So the moons have aligned. All right, so we'll go into our Connect 4 game. And we'll go ahead, we'll give ourselves a private char cur move. And we'll say this dot cur move is equal to, let's go ahead and start it off as red, because you got to have fire before you got smoke, right? International Connect 4 professional rules. You got the same thing in cricket or whatever, don't you? Isn't there like which team goes first? The home team? There's a toss always? Really? Cricket's kind of like the made-up baseball, right? From an American's perspective, cricket's the made-up baseball. Well, so in baseball here, the home team bats first. I'm sorry, no, they bat last. So they always have the last chance to win at the end. So it doesn't matter who the home team is. There's no advantage. Okay. See, that's what I mean. It's made up. It's a made-up sport. What was I doing? Oh, cur move. Red comes before black because you need fire before smoke, right? Except if you're starting a campfire, don't you see the smoke before the fire actually starts? I don't do a lot of camping, but I've seen it on TV. That Bear Grylls guy, you know what I'm talking about? It's like a survivalist guy. He takes these celebrities out and they climb mountains and stuff. Doesn't make any sense to me. All right, so we'll still do the wild true thing because really this is going to be, as long as there isn't a winner, let's let this guy keep rolling, right? So we'll show him the board. We'll ask him for a column. We'll get the column, but then we need to see if a move was actually made. All right. So remember, we have our make move returning true when a move was made and false otherwise. So if we did make a move, then we want to go ahead and toggle our cur move. So we'll say if this dot cur move is equal to R, then this dot cur move is equal to B. Else this dot cur move is equal to R. All right, so we're going to toggle back and forth between R and B. Make sense? All right, so now we should be able to run this again. Should do the same thing it did before, except we should see for legal moves it'll bounce back and forth between our moves. All right, so we'll choose column 0 again. Oh, it could bounce back and forth between those if we actually told it what the current move was. So we're not just going to assume it's a 0. We're going to have make move take in the column we're going to drop the checker into, as well as the checker we're dropping. All right, which means that now back here in Connect 4, we haven't given this guy enough parameters. This needs to take current move as well. So when we make our move, we're going to choose where and what checker we're dropping. All right, so there's our all right, so now seem to be toggling back and forth. Okay, so now we need to be able to check for our winner. Okay, now for the homework, you only needed to check for horizontal, vertical winners, All right, up and down. That should have been really easy.
Except there are like so many combinations, like it could be 0, could be.
Oh, now I remember why I made it this way, because I tricked you. So, how many of you wrote? If we go back to our tic-tac-toe board, actually, it's in just board, right? Something like this: the epic Connect 4. Is there a vertical winner Boolean expression? Where there's like, how many words? Like 20 or 25 different? There's a lot, right? How many of you wrote that? You tried to and then you just gave up? How many of you wrote something else that worked? Versus how many of you just gave up? It's like I didn't do it. It's what is what happened. All right. Oh yeah. So this was the trick. In tic-tac-toe, this is okay, right? 8 Boolean expressions, not the end of the world. Okay. But now we have a lot. What if I had? So imagine your mindset saying, okay, well, I'm going to check for, if you're just checking for vertical winners exhaustively with every single possible way there can be a vertical winner. What if I had then thrown in there horizontal and diagonal winners? You would have like 200 Boolean expressions or something. Okay, it would have been crazy. Okay, if we look at the board here, how is there a vertical winner in column 0? How can we detect if there's a vertical winner in column 0? Let's just focus just on that one column right now to kind of stumble upon the logic for it.
There's a 4 consecutive rows with the same symbol.
Okay. So when we have the same symbol, that's not the underscore. 4 things in a row, right? Would we always start checking from the bottom?
No, from the current row.
Well, okay, you could. And we did the same thing with with tic-tac-toe. We could keep track of what the last move was. And we could say, okay, was the last move involved in a winning move? That would probably be better anyways. But to keep things disconnected, I want to say, is the current board in a winning state? Which means I want to check the entire board. All right, even though you're right, we only really need to look at what's around that last checker, right? Because if things have changed from the last move, it was because of that last drop checker. Okay, but we'll go ahead and check everything. So if we're just looking at column 0 here, how do I know whether there was a winner in column 0? I'm always going to start here at the bottom, right? Because checkers pile up from the bottom. So if I come down here and I find we're looking for streaks, right? We're looking for a bunch of red checkers in a row or a bunch of black checkers in a row. That makes sense? And we know that we could exhaustively go through all of these guys. So the 6 rows here, counting streaks. But as soon as we hit an underscore, we know we're done. Correct? Because that means if we hit an underscore right here, we know there's no more checkers above that guy. Because of the way the board works. The board works on gravity, right? The checkers drop down and go all the way down as far as they can go. So if I start here at the bottom and I say, is this guy something other than an underscore? If you want to look at this one, is this guy something other than an underscore? Yes, it is. Okay. Is he red or, in this case, yellow? He's red. Okay, so we're going to add our red streak we're going to make it a 1. We found another one. Red streak is now 2. Ah, we have a new winner. Red streak goes to 0. Yellow streak is now a 1. Then we hit the end. So in this vertical column, none of our red or yellow streaks hit 4. Highest we had is 1, not a winner in that column. That makes sense? So we need to write that logic, so we're going to have streaks in an individual column. So we go back here to C4 board. All right, so we're going to have an int red streak, and we're going to have an int black streak. And we're going to check each of our columns, right? So we're going to have a for loop. We know exactly how many columns we have. So for int I is equal, actually let's do for int col is equal to 0. I is less than this dot the board. Now, if we say dot length here, that gives us the number of rows. That will give me the number of columns. The length of the array that lives at bucket 0. Since we know this is that every row in this guy has the same number of buckets in it. Okay? So this will boil down to a 7 in this example. And it's not I, it's col. Then we'll say col plus plus. So this for loop will go from column 0 to column 1, to column 2, to column 3, all the way to column 6, right? For each of those columns, we want to say, is there a vertical winner in this column? That's the question we were to ask on the homework assignment, right? All right, so how do we look for vertical winners in this? Well, we're going to use our red streak and our black streak values. So we'll say red streak starts off at 0. Black streak starts off at 0. And then we're going to have a current row, just like before. And we'll go ahead and define current row out here. And we'll go ahead and we'll say cur row is equal to the last legal row, which is going to be this dot the board dot length minus 1. Right? That's the farthest down checker in this column that we might have. So that is the length of our array. Because remember, a two-dimensional array is an array of arrays. So bucket 0 right here has an array out this way. Bucket 1 has an array. Bucket 2 has an array. So our total array's length is 6. Last legal bucket is length minus 1, this guy right here. Okay? So my cur row is going to be 5 in this case when I start. Because I want to start here and working my way up in the current column. All right, and I'm asking myself, I want to keep working my way up as long as I have not hit a underscore. Correct? And cur row is not equal to -1. It's greater than or equal to 0. All right, so we're going to say while cur row is greater than or equal to 0. So while we still have things to check, and this dot the board at bucket cur row col is not equal to an underscore. All right. So while we're looking at something that is not equal to an underscore and cur row is still a legal position, we know we're looking at either a red checker or a black checker. Now, if it's a red checker, and this is the first in our streak of red checkers, then we need to zero out black checkers and add 1 to red checkers. So if this dot the board at cur row call if that guy is equal to red. Now we would not be in here if it wasn't red or black. It's red or black, because if it was an underscore, we would have failed on this while loop and we would have dropped past it. So we're only inside this while loop here if the checker we're looking at is either a red checker or a black checker. Okay, so if it's equal to a red checker, then we'll ask the question, if red streak is equal to 0, then that means this was the first red checker we've bumped into in the current streak. So we'll go ahead and say red streak plus plus, but we'll also say black streak reverts back to 0. If it happened to be something like if we had 2 black checkers in a row, and then also we hit a red one, now we have a red streak of 1 and the black streak goes down to 0. Wasn't enough. Okay? Else, actually, you know what? We could just do this. We don't even have to ask if we wanted to be explicit about this, we would do this. If red streak is 0, increment red streak, set black streak to 0. Otherwise, we could just increment red streak. But the reality is, if we're in the middle of a red streak, it's not hurting anything to go ahead and set black streak to 0 over and over and over again, as we were finding, it's like, oh, this is your third red checker. No problem. By the way, black streak, you're still 0. You still got nothing. All right, so so we could just do this. And this is probably more efficient than asking the question each time through. They're both fine. Neither one is a problem. So if we're looking at a red streak, or a red checker, increment red streak, 0 out black streak. Else, increment black streak, 0 out red streak. Make sense? Now, when we exit this while loop, we have finished with a column. We either finished naturally because we ran out of rows to check, or we finished because we hit an underscore, which means we ran out of checkers to check. In either case, red streak and black streak are going to be values that might be 4 or more, right? So we can ask the question, if we actually don't even need to do if. What we can do is we can say return. Let me write it as an if, and then I'll explain why we just do it as a return. We could say if black streak is greater than or equal to 4, or red streak is greater than or equal to 4, we can return true for that column. Actually, we would need to do it in an if this time. And I'll show you why here in a second. I was originally going to suggest we do this. Just return black streak greater than or equal to 4 or red streak greater than or equal to 4. This is a Boolean expression. This guy's going to be true or false. This guy's going to be true or false. Notice that with our if statement here, we're only going to return true if we did have a winner. Otherwise, we need to keep cooking and go and check the next column. Let's not check columns if we've already found a winner. All right, but I can't just return my answer right here because I might not be done. If I didn't have a streak, a winning streak in column 0, I'm not going to return false. There is no winner in the entire board because I have all these other columns to check. That make sense? Go ahead.
In this code, we might never hit a case that's greater than 4 because we are checking every time we finish a movement. So legal should be equal to 4, not greater than equal to 4.
No, we would do greater than or equal to 4 because we might have I understand what you're saying. because we intend to check after each move. You're right. We would never actually have a value greater than 4. But this still is not incorrect, right? But you're right. You're right. Because we intend to call is winner after every single individual move, there would never be 6 red checkers in a row. That's not something that would happen because of the way we intend to use this tool. Now, that doesn't mean that we can't still ask the question, is it greater than or equal to 4, as opposed to saying if it's equal to 4. If either of those is equal to 4, return true, we have a winner. We know that both of those things mean the same thing for us, given the way that we are going to call this function. 4 in a row is the same thing as greater than or equal to 4 in a row, because we know it will never be higher than 4, since we're checking it after each move, unless somebody moves twice without us checking. Okay, we're not going to allow that. But logically, this guy doesn't presume how we're going to use this function. So it's actually a good point you made. That is, since we know how we're going to use this, we could ask a different question here. But because we're asking the kind of the globally, this is an uncoupled solution. That means that our solution here is strictly asking the question, is the current state of the board representative of a winner state? This pays no attention to when we're going to call this. Does that make sense? So by us saying greater than or equal to 4 here, we've uncoupled this logic from however we might use this. This function right here always returns true if the current state of the board has a winner, and false otherwise, regardless when we called it. All right? So that's when we'll return true there. If we didn't return true there, that means there wasn't a vertical winner in the current column, this guy right here. Therefore, we should go on to the next column and check there, where red streak, black streak, and cur row all reset, and we try again. Okay? Now, if we're still cooking here after we've tried every single column, and we still don't have a winner, we'll return false. No winner. That make sense? All right, so go back to connect 4. So now instead of saying while true, we'll say while this dot the board dot is winner, and if we want to match it up to what we said last time, is equal to false. Remember from last time, you can also say it's not a winner. So while not true is false, not false is true, so this flips the sign. So if we say, is there a winner? Not that means is winner returned false. As long as this guy is true, keep going. So this and this mean the same thing. Most beginning programmers like this better, but it is redundant. We're saying if false is equal to false, which would be true, then keep going. So it's actually a redundant statement. We're saying false twice. But if it reads better and you understand it better, that's fine. So we'll leave it here. All right. So when we play, we're going to keep playing as long as the board doesn't have a winner in it. And then we'll toggle back and forth between our winners until we finally get a winner. But right now, the only way we can win is with vertical wins, right? So we'll go back here. Let's go ahead and run it. So here's our current thing. So we'll go column 0. Bro. I have an infinite loop. Let's go back to our board for is winner. Column 0. Well, cur row. Oh, we're never actually decrementing cur row. We need to work our way towards the top, right? Cur row minus minus. We were just checking the bottom thing over and over and over and over and over and over again. Never actually moving towards the top. All right, so there's that. And let's just toggle back and forth between these guys. And we should get a winner here. Oh, I never actually said winner, but it's done. We have a winner. All right, questions about that?
How do you check the other columns?
What do you mean? How you check for horizontal winners, or what if I had a winner over here?
No, the vertical and the other columns. I thought we were just going for column 0.
Well, we used our example here when we were talking about it as column 0, but we are checking all the columns potentially. That for loop right there will take us through column 0 to column length minus 1. So if we didn't, this is the current column. This is all the logic we do for the current column. Let's go down a little bit. Right there. That's the logic for the current column. We reset all of our variables. We go to the very bottom and start working our way up. And if we're finding red streaks or black streaks, we're incrementing those variables and resetting the other variable, moving our way towards the top. As soon as we either hit the top of the column or we hit an underscore, we break out of this while loop. And that's when we ask the question, did we have 4 in a row? If we did, we have a winner, return true. But if we didn't, we spin back up, we move on to the next column. Col plus plus. So that'll check column 1, then column 2, then column 3, and then column 4. Does that make sense? Because as we played this game here, and I made a move in bucket 0, it just checked the entire board. It said, is there a winner in this column, this first column? No. Okay. Is there a winner in this column? No. Is there a winner in this column? No. Is there a winner in this column, this column, this column, this column? No. Return false. So that return false is this guy down here. I've checked everywhere and there are no vertical winners. All right, that's the guy we just saw.
So if we're supposed to do our cur move, how would we say cur move plus 4 or minus 4? You know, like right now, the solution we want was to check the whole board.
Mm-hmm.
So if we're doing it around cur move, how would that?
Okay, so well, cur move, the way we have it is a checker, right? It's a checker color, either black or red. If you wanted to do it relative to the last move, you would have to ask what column was the last move, and then check that column for a winner. Specifically, you could so we could have omitted, you know, when we do is winner here, we could have this guy take in an actual column. The column that the last move was made in, and have it, instead of having this for loop potentially check every column, it would only check the column that we passed it, because that was the column that was involved in the last move. If you want to get even more precise than that, the last move could be made, we could find out what row it was made in, and then you could check it relative to that row. But I would think that would make it significantly more difficult. So... But the reality is checking a Connect 4 board is pretty fast. So this kind of comes back to that coupling type thing. If we rely on somebody else saying, go ahead and check the board, but only around this column, now this function is then reliant on another part of our program. As I have it written right here, this function right here always returns true if somewhere on the board there's a winner. Always returns false if there's not, regardless of, you know, what was the last move made, regardless of anything else. It stands on its own as checking the board for a winner. That makes sense? Okay. What if we wanted to do horizontal winners? Or diagonal winners. How much worse is that? All right, let's take 10 minutes. Take a 10-minute break, run to the restroom, whatever. We'll come back. Let's write horizontal and diagonal winners. Complete our Connect 4 here. And then we'll move on to a significantly harder thing because this was too easy, right? All right, but I think this is the solution to the homework. Is that accurate? Does that sound right? This is what you had to do for your homework? All right. So come back at 7:20.